Hello, sixth graders. You've been studying metric conversions in your science class, and hopefully you'll get to that as well in your math classes, or maybe you've had it before if you've had the sixth grade standards taught to you. Um, a couple things that we want to talk about in the past, or maybe one method that many of you have used for metric conversion is your King Henry method. So King Henry died by drinking chocolate milk. And so when you've done that, you've figured out that, all right, if I'm using this M milk, which actually stands for milli, and we want to go to the base, so we'll say meters, we would just move the decimal place 1, 2, 3 places to the left. Okay, so going from millimeters to meters, we would move that decimal 3 places to the left. So what I want to do today is just kind of show you why these things happen and show you just another method in a way that you can prove it mathematically. So I'm going to use this main chart right here with our length, our mass, and our capacity. We're going to use those rates, those conversions. 1 centimeter is equal to 10 millimeters, and so on and so forth. And we're going to create equivalent ratios. So I'm going to start off with right down here, 496 millimeters. We're going from millimeters to centimeters. If we did that, according to King Henry, we would move from right here milli to right here centi. We essentially would lose 1 decimal place, and our answer would be 49.6 centimeters. I'm going to show you another way to set this up, and one way to set this up is by using this conversion right here. If I know that 1 centimeter is equivalent to 10 millimeters, I can use 1 centimeter is the same thing as 10 millimeters. And then I'm going to make that equivalent to, we're going to try and figure out what this 496 millimeters is. So I'm going to create another ratio. I don't know, oops, I did that wrong. I should say centimeters. I apologize. I should say centimeters here. We're going to make that equivalent to 496. We know 496 millimeters. If my millimeters is on the bottom right here, I need to put that 496 right there. And then I'm going to put my centimeters on the top. And what this is doing is saying that, all right, 1 centimeter is equal to how many centimeters when we have 496 millimeters. So one method that I always talk about in class, and it's a method that you've used before when dealing with especially fractions and making equivalent fractions and simplifying fractions. You have taken this and found the magic, I call it the magic number. So we know that 10 times a number will equal 496. We know that 496 divided by this number should equal 10. And then we follow the rule, whatever we do to the bottom, we have to do to the top. So what I want to figure out is what is that magic number? So I'm going to use a calculator, or I guess I don't have to because I'm just going to be dividing by 10, so it's really not that big of a deal. I'll take 496 and I'm going to divide that by 10, okay? And that will give me this number right here, okay? So 406 divided by 10 equals 49 and 6/10. So I know my magic number right here is 49 and 6/10. I know my magic number right here is 49 and 6/10. So 496 divided by 49 and 6/10 will give me 10. If I take 10 and multiply it by 49 and 6/10, I'll get 496. So I need to do that exact same thing for my centimeters. And this will give me how many centimeters 496 millimeters is. If I have 1 centimeter for every 10 millimeters, I can do 1 times 49.6, and I would get 49.6 centimeters, which I believe I said would be the answer before if we use that King Henry method, starting at millimeters and moving to centimeters. We'd just move that decimal place 1 place to the left. So just another way to look for you to look at how to convert and find these things. We can show it proportionally. We have 2 equivalent ratios here. 1 centimeter is 10 millimeters. if we want to know how many centimeters 496 millimeters is, the answer is 49 6/10 just by using that conversion piece. So I'm going to show you a couple other ways here. We're going to be moving on to mass here and talking about kilograms and grams. If we were doing this using King Henry, we would start at kilograms and we'd be going all the way to the base right here. So we'd move the decimal place 1, 2, 3 total spots. I believe that would give me an answer of 680 kilograms. So we're going to talk about how we can do that here. I'm going to use this conversion right here. We know that 1 kilogram is 1,000 grams. So I'm going to write that down. 1 kilogram for every 1,000 grams. And then what I'm going to do is take the information from this problem and put that in. It is saying that we have 68 hundredths of a kilogram. That's less than 1 kilogram. So we know when we get done, our grams are going to be less than 1,000 grams because we don't have 1 full kilogram. So what we need to do is figure out how do we get this number right here to that number there. Well, one way we can look at that is to get to 1, we know that if we take any number and divide it by itself, so if we take 68 hundredths and divide it by 68 hundredths, we will get a grand total of 1. So I bet you anything my magic number, and I kind of ran out of room, is going to be 0.68. I'm going to make a bigger circle there. Okay, so from going from here to here, we would divide to get to right there. That means going from 1, and if we multiply 1 by 68 hundredths, we will get this number. So let's do the same thing. Let's take 1,000 and multiply it by 0.68. So I'm essentially, my answer in grams will be 1,000 times 68 hundredths. So 1,000, and we multiply it by 68 hundredths, we will get 680. Now, if you look at that, typically when we multiply by tens or divide by tens, and this is why the metric system is so great, if we count the zeros, that tells you how many places we're going to move the decimal place, and we'd move it 1, 2, and add 1 more for 3. That's how we get the answer of 680. So my answer is 680 grams. And if you notice, again, we needed 1,000 grams to get to 1. We don't have 1,000, we only have 680. We would essentially have 680 out of 1,000, which would give us our total number of kilograms, 68 hundredths. So just another way to look at it and another way that we could convert. Okay, I'm going to move on to the next question from milliliters to liters. So again, we're using capacity now. We're using milli. This is milliliters, and we're going to go to the base. And if you did this using King Henry, you'd move it 1, 2, 3 spots to the left. Okay, so essentially if we did that, we'd have 3.8 liters. Well, what I want to do is I want to use my conversion. I want to know milliliters to liters. And I'm getting really lucky today because look at what we have here. I know that 1 liter is equivalent to 1,000 milliliters. So I'm going to use that. I'm going to use 1 liter is equivalent to per 1,000 milliliters. And we're given a total number of milliliters right here. We have 3,800 milliliters. And we can do the same thing, or I can show you my least favorite method. And that is using cross products to solve. So one way that we can do this, we can find whatever you do to the bottom, you have to do the top. Otherwise, what we can say is that we know if these two numbers are equivalent, we should be able to multiply their cross products by each other and they should be equal. So if I take 3,800, I'm going to write that right here, 3,800, and I multiply it by 1 times 1, that should be equivalent to 1,000 times our liters, which we don't know what that is. Okay. So now essentially what we have to do is we need to get this L all by itself. So we would just divide by 1,000 on each side. And that would get our liters by itself. And 3,800 divided by 1,000 gives me 3.8. And again, because we're dividing by a tens number, it's 1,000, we'd count the decimal places. And because we're dividing, we just lose 3 spots. And that's how we get our answer. So it'd be 3.8. So a simple way that kids do this is they do 3,800, they multiply it by 1, and then they divide it by the other number that we know, 1,000, and we'll get that answer every single time. So hopefully that helps you out, and you can use either cross products like I did there, or whatever you do to the top, you have to do to the bottom. All of those methods will work to solve these problems. The main thing that we need to know is we need to know these conversion rates right here. You know, how many centimeters or how many millimeters are in a centimeter? How many centimeters are in a meter? How many millimeters does that mean? And some of you may have to do multiple conversions to figure it out, but you can certainly, once you get this piece down right here, and then you have one other piece of information, which I believe was this on this problem, you can easily find that missing number by setting up a proportion. So good luck, give it a try, and hopefully that helps you out to learn another way with metric conversions.